Okay, so I'm going to start this video right here on number 8. There's already a video explaining all this stuff, but I want to re-emphasize different ways of comparing fractions. So 4/5, you could actually divide 4 divided by 5. A fraction is really a division problem. And on a calculator, that will give you the decimal 0.8, right? And if you do 9 divided by 10 on a calculator, it'll give you 0.9. So now you're able to compare decimals pretty easy. Which one's bigger, 0.8 or 0.9? 0.9 is bigger, so it would open up that way. Another way of comparing fractions, besides doing division and changing them to decimals, another way would be to get a common denominator. So this one's 10. This one could be changed to 10. So make that denominator 10. This one's already 10. How could you change 5 to become 10? You multiply by 2. You multiply by 2. So this becomes an 8. And that other one started with the 9. It stays a 9. So now you could compare numerators. Which one's bigger, 8 or 9? Well, 9's bigger. That's why you open up to the 9. So there's different ways of comparing fractions. You could change it to a decimal by dividing, or you could change them by getting a common denominator and then comparing the numerators. Or you could also think of it visually, but I don't recommend the visual unless you're trying to explain what fractions are to somebody that doesn't know what fractions are. So number 9 right here, I have one fraction and one decimal, so it'd be better to change them both to be the same type of thing. Either change this guy to look like a fraction or change this guy to look like a decimal. What do you guys want to do? Change this to a decimal? Okay, so this is 1 divided by 5. If you did 1 divided by 5 on a calculator, it will give you 0.2. So what could you tell about the fraction 1/5 compared to this decimal 0.2? They're equal. Now let's say you didn't have a calculator, all right? You could take the numerator 1 and divide it by 5 on paper, right? How do you convert a fraction to a decimal? You could put 1 divided by 5. The number in here is the one that's being divided by this. So 5 times what equals 1? It doesn't work. So you'd have to put a decimal right here and add a 0, so it'll look like a 10. But this decimal will simply come right up, and you'll put that decimal right here. So then you think 5 times what gives you 10? 5 times 2 gives you 10. So that's why you put a 2 up here. And of course, when you put the 10 down here and subtract, there's no remainder. There's your answer. So you see how I converted it? I got the same decimal without a calculator. Obviously, with the calculator, it's easy. Just 1 divided by 5, you get 0.2. But if you wanted to, you could do it by hand. Put the 1 on the inside of the division box, the 5 on the outside, and then put a 0.0. That way it looks like a 10, and you say 5 times 2 is 10. So that's why the answer is 0.2. So when you compare 0.2 with 0.2, they're exactly equal. This one's pretty easy. Which one's bigger, 0.099 or 0.1? 0.1. It's all about the decimal places, right? This first one is 0, and this first one is 1, and that's what we're comparing. We're comparing 0 with 1. 1's bigger. That's in the 10th position, by the way, so that's why the 0.1 is greater. Number 11, which one's bigger? The positive one or the negative one? The positive one. Positive numbers are always greater than negative numbers. Which one's greater? The negative 0.99 or the negative 1? Negative 0.99, right? Not because 99 is greater than 1, but you got to think about the number line, right? So let's say that we have 0 right here, and let's say negative 1 over here. So where would negative 0.99 be? Where would this one be at? In between 0 and negative 1, super close to negative 1. So negative 0.99 would be right here, and negative 1 is obviously right here. So which one's on the right side? The one on the right side happens to be the negative 0.99, which means that this guy is greater. So your answer has to be opening up to the negative 0.99. Number 13, how could we do this? I'm not even saying what's the answer. I'm asking you, how could we do this? Divide 2 divided by 8. Okay, so if we did have a calculator, we would get 0.25. Or you could reduce before you divide, right? You could reduce it by 2. Always reduce fractions. That'll become a 1 over 4. So 2/8 is really 1/4. And if you think about the fraction 1/4, that's saying 1 out of the 4. 0.25 is kind of like saying 25 cents, and there's obviously 4 quarters in a dollar. So 1/4 and 0.25, they are equal to each other. Now let's say you didn't have a calculator and you can't divide 2 by 8 or even 1 by 4. You could write it down on paper, put the 1 on the inside of the division box, the 4 on the outside. So 4 goes into 1 how many times? It doesn't work, right? 4 times 1 is 4. It's not even 1. So what I want to do is convert it to a decimal by putting a 0.0. And I want to go 4 times 2 will get me close to 10 without going over. That'll be 8. Now when I subtract, 10 take away 8 is 2. Right? So then I add a 0 and drop a 0. And then I say 4 times what gets me 20? Well, that would be a 5. 4 times 5 is 20. And let's not forget that we put a decimal here, which means that there's a decimal up here in front of the 25. So it's really a 0.25. So that's how to convert it by hand on paper if you don't have a calculator. So anyways, as you can see, 0.25 and 0.25, those guys are equal to each other. All right. So before we move on to this next section, let's flip back over to the front side. Okay, guys, so let's go to this third part of our notes on the bottom of the page. It says converting a fraction to a decimal to a percent. All right, so we've already been converting fractions to decimals. All you have to do is divide the numerator, the top number, by the denominator, the bottom number. The top number goes inside of the division box, add a decimal to it, the bottom number goes outside, all right? So give me any fraction, guys, any fraction you want.
1/8.
1/8. Ladies and gentlemen, the fraction 1/8. If they ask us to convert it to a decimal, all you do is put this top number inside the box and the 8 on the outside. I'm sorry, that looks like a square root. So there's your division box, 1 divided by 8. So 1/8 is really that division problem, 1 divided by 8. So we put a decimal and a 0 so it looks like a 10. Okay. Now 8 times what gets us close to 10 without going over? 1. So that decimal, this decimal down here, we're going to put it up here. So let's put that decimal right up there. And you guys did say that it's going to be a 1 right there. So you just go through it normally, forget about the decimal for a while. 1 times 8 is 8. So you really have what looks like a 10, even though it's not a 10, there's a decimal there. It looks like a 10. 10 take away 8, that's 2. Okay, then what do? We add a 0 and drop a 0. So then you think 8 times what gets us close to 20 without going over? 2. All right, so let's put a 2 right here. Let me make this division box longer. 8 times 2 is 16. So I want to put minus 16 right there. Yeah, this one's kind of has a lot of steps. 20 take away 16 is what? 4. All right, so I have a 4 here. Again, I add a 0 and drop that 0 so it looks like 40. And finally, 8 times what is 40? 5. So we finally finished right there. We got that 1/8. 1/8 is really 0.125. So that's how you convert a fraction to a decimal. And we actually did that a couple of times just a couple of minutes ago on this video. Okay, and they also need us to convert a decimal to a percent. Okay, converting a decimal to a percent. So what is a percent? A percent means per 100, right? So whenever like you hear coaches tell like their players, come on, give 110%. That's impossible. You can't give 110%. 100%. No, it would be actually not imaginary. 110% would actually be a mixed number, right? Because it's actually a fraction. Any percent is really a fraction. You see, percent means per 100. So if I say 50%, what fraction is that? What's 50%? It's 50 over 100. Percent means per 100. If I say 10%, what's 10%? That's 10 over 100. Percent means per 100. So anytime you have a decimal, anytime you have a percent, you just put it over 100 and bam, you've converted your percent to a fraction. But right here, they want us to convert a decimal to a percent, okay? A decimal to a percent. So if I take that same answer that I got right here, this decimal, the 0.125, 125, and they want us to convert it to a percent, we move it 2 times to the right. So the decimal point goes 1, 2. So what's our percent really? It's 12.5%. You could still have decimals and percents, but that's your percentage right there. Okay. Ladies and gentlemen, what would 1 as a percent be? Like the number 1, let's say the decimal 1.00 as a percent, what would that be? That'd be 100%, right? 100% means all of it, right? If you're giving 100%, what does that mean? You're giving everything, right? If you're going to eat 100% of a pizza, what does that mean? Eat the whole thing, right? 100% means the whole thing. That's why the number 1, the whole number 1, or the natural number 1, but the whole thing, 1, means 100%. Okay, so if you were to move it 2 over, that's why you'd end up with 100 as a percent. Okay. One more thing, let's see. Let's move on to part 4. Perfect square numbers approximating radicals, or approximating square roots, probably should have said. So we already know, or we should know, how to create this list from scratch, right? Where did 1 come from? From taking the number 1 and squaring it. 1 times itself is 1. Where did 4 come from? 2 times itself is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 6 times 6. And we've already discussed this in previous lessons, that the square root of a perfect square number, these are all perfect square numbers. If you take the square root of any one of these guys, you're going to get a nice, beautiful, perfect answer. The square root of 64 is what? 8. The square root of 9 is what? 9. Square root of 9. 3. Why? Because 3 times 3 is 9. Square root of 25? 5. Why? Because 5 times 5 is 25. The square root of 121? 11, because 11 times 11 is 121. Yeah. The square root of 36? 6. There you go. All right, so taking the square root of any of these guys, it's beautiful. You get a nice, perfect answer. Now, when you don't take the square root of one of these, you end up with what we call an irrational number, a crazy decimal that doesn't repeat, that continues forever, right? Doesn't have a pattern. So if I said the square root of 26, that's going to be a crazy decimal. But I could actually approximate the square root of 26 because I know the square root of 25 is what? Square root of 25 is 5. So the square root of 26 has to be just a little tiny bit more than the answer of the square root of 25, which is 5. So what's a little bit more than 5 as a decimal? 5.1. And you put this approximation symbol right there on number 1. Okay? Now, let's look at this example that I actually wrote out and gave you the answer to. The square root of 91. Where the heck's 91 at? Well, 91 would be almost perfectly between 81 and 100, right? 91's 10 away from 81. 91's 9 away from 100, so it's almost perfectly in the middle. You guys agree with that? Yeah. Okay, so what would that decimal approximation be? That'd be pretty much in between the answer of the square root of 81 and the answer of 100. So what's the answer of the square root of 81? The answer to the square root of 81 is 9, right? And since 80 is right before 81, this answer has to be right before the answer 9, like super close to it. So that would be what?
8.5.
8.9.
Oh, 8.9.
Right? Do you guys get that?
Yes.
Like, think about it. Yeah. The square root of 81 is 9. The square root of 80 is right below that answer. Right below that answer. So right below 9 would be 8.9. Yes. Okay? Now, 111. Is it really close to 100? Is it really close to 121? Or is it about in the middle? It's about in the middle. So your answer is going to be about in the middle of the answer 10 and 11. So what's your answer going to be? 10.5. So we're going to put approximately 10.5. We know that if we actually did the square root of 111 on a calculator, it would be irrational. All right, now how about the square root of 48? 6.9. Because the square root of 49 is 7. 48 is a little bit less than 49. So the answer that's a little bit less than 7 would be 6.9. Okay, let's flip back to the backside. I would like you guys to now practice these radicals by giving a decimal approximation, okay? So I want to pause it right here. Let me just start out for number 1. 24 is really close to what perfect square number? 25, right? So it's really close to 25. It's just 1 away from it. So what's the answer to the square to 25? 5. So what does this answer have to be? It has to be really close to the answer 5. So yes, 4.9 is your answer. So everybody do this. Put a squiggly, 2 squiggly equal signs right there. 4.9. Okay. Of course, you need a perfect square number list to do these really well. So you might want to jot down a perfect square number list right here. Like 4, 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. That way you could see where the square to 20 is going to land. Where's the square to, or actually 145. We need to make this bigger to get to 145. So we have 100, 121, and 144. So where would 145 be at? It's a little bit more than 144. What's the square to 144? 12. So what would this answer be? 12.1. You guys got it. So go ahead and finish these up. 12.1 is the answer number 2. And I'll share with you the answers in a moment. Hit pause if you're at home watching this for the first time. So here are your answers. And you should be able to see where I got these answers from. If you have your perfect square number list, you'll be able to see like 120. Where's 120 at? It's a little bit less than the square root of 121. The square root of 121 is 11. So a little bit less than 11 would be about 10.9. Now I saw some of you put like on this one 72. 72, where's that at? It's pretty much in between 64 and 81. So that's why the square root of 64 is 8. The square root of 81 is 9. So the answer is in between 8 and 9. So I put 8.5. I saw some of you put like 8.4 or 8.6. It's okay. I'm just looking for an approximation. If it's pretty much in between, an 8.5 or a 0.5 is good enough. If it's really close to something but less than it, like on right here, 120 is pretty close to 121, but it's a hair less than the answer of the square root of 121. So it's a hair less than the answer of 11. So 10.9 would be good right there. So what do you guys think of these answers? Hopefully you got them. This next section, it says decimals, percents, and fraction. What is a percent? We just said that a percent is per 100. Okay, so everybody write that down right there. It's super small, that space, but per 100. It's really a fraction, right? And that fraction is going to be over 100. 100 will always be the denominator when you convert a percent to a fraction. So when we look at number 1, 3%, they want us to convert the percent to a fraction. What is 3% as a fraction? 3 over 100. Easy. How about number 2? 7 over 100. How about number 3? 10 over 100. Isn't that easy? Now, okay, we can't just, it can't be that easy, and it's not. Because like on number 3, when you get 10 over 100, you could reduce that. And anytime you have a fraction that you could reduce, you should reduce. Yeah, you have to. Let's not think of right and wrong. Let's think of understanding it the best. So whenever you have a fraction, you should reduce if possible. Because it's easier to think of reducing by 10 on both of those or canceling out zeros. 1/10 is a lot easier to think about than 1/100th. But either way, 10 over 100 is the correct fraction for 10%, but you should reduce if possible. So number 4, it's 15%, so you're going to do 15 over 100, but then what are you going to reduce by on that one? Reduce by 5. So if you reduce by 5, I want to put a little division of 5 right there. 15 divided by 5, that becomes 3, and 10 or 100 divided by 5, that becomes 20, right? So 3 over 20 is the reduced fraction for 15%. 75%, that becomes 75 over 100. What does that reduce down to? Think about quarters. How many quarters are in a dollar? 3 out of 4, right? 75 cents, there's 3 quarters out of those 4 quarters that make a total of $1, which is 100 cents. In reality, all I did was divide top and bottom by 25. 32%, What do I write it as?
32 over.
32 over 100. There you go. And I could reduce at least by what? By 2. If I reduce by 2, what does 32 become? What's half of 32? 16. And half of 100? 50. Could I reduce by 2 again? Yeah. So when I reduce by 2, what do I get up on top? 8 over 25. That's all you could do. There's your answer. So 32% is really the fraction 8 over 25. Number 7, 6%. What am I going to change that to? 6 over 100. Percent per 100. It's always over 100. What could I reduce by? By 2. What's 6 divided by 2? 3. 100 divided by 2? 50. 3 over 50. Can't do anything else with that. That's your answer. 3 over 50. Moving on to number 8. 80%. 4/5. How did you do that? You don't know. What?
No, I'm just kidding. I converted it into
80
over 100.
over 100. Perfect. And then?
I divided it by each by.
Then you reduced it, right? Yeah, and you're absolutely right. Now, whenever you see a 0 on top over a 0 on the bottom, you can just cancel those out and it becomes 8/10, right? And then the 8/10 you could reduce by 2, and you will get, if you reduce by 2, reduce by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. So yes, the answer is 4/5. Good job. 48%. What do I do there? 48 over 100. And I could reduce by 4, actually. Yeah, if I reduce 48 divided by 4, what do I get? 12. If I reduce 100 by 4, 25, right? There's 4 quarters in a dollar. So 12 over 25, you can't reduce by 2 anymore. Could you reduce by 3? Nope, that's it. That's as far as you could go. There's your answer, 12 over 25. Guys, keep in mind, every type of these questions will be on the quiz Friday. So I hope we're all paying attention. We're all understanding. Okay, so I would like you to continue attempting to do this for homework tonight. Convert the following decimals to fractions. So how do you change a decimal to a fraction? You know what? Before we end this, I need you guys to understand how to convert. We already know how to convert a fraction to a decimal, but I need you to be able to go backwards, a decimal to a fraction. So on number 10, we need to know, actually let's go up here and do some side notes. Let's do a decimal, 0.1234. Okay, now the 1 is technically in the tenths place, tenths with the THS, tenths. The 2 is in the hundredths.
And then thousand.
Yep. And then thousandths. And you know what? Let's just stop right there. Let's make it a 0.123, yeah? Now, the thing is this. If I told you to convert, let's say that right there, convert this to a fraction, how do you read this? You read this as 1/10. So this would be the fraction 1 over 10. If I showed you just 0.12, and you would read that as 12 hundredths, so you put 12 over 100. If I told you convert that whole thing, the 0.123, yeah, this is going to be the fraction 123 over 1,000. That's how you convert decimals to fractions. So please work on this for homework, and we'll review it tomorrow.